Welcome everybody to the Cloud Online Meetup. Today with us is John Wetherill from ActiveState. And today's topic is going to be an introduction to Platform as a Service, or better known as PaaS on OpenStack. And John is going to cover a few topics, which is obviously an introduction to PaaS, the relationship between IaaS and PaaS layer, an explanation of the PaaS architecture and how to provision services such as databases, messaging systems, caching services, and file systems. And lastly, how PaaS interacts with OpenStack. We're going to have three parts. The first part is going to be a presentation. Then the second part is going to be a demo. And last but not least, we're going to have a Q&A session. In case you have any questions, feel free to share those through the chat window on the left-hand side of the web panel. And the recording as well as the slides are going to be available approximately 24 hours after this session. And with that said, let me hand over to you, John. Why don't you go ahead and introduce yourself as well as ActiveState.
Hi, Raphael. Thanks for inviting me to this webinar. I appreciate it. It's great to be here. I've been plugged in a little bit to the OpenStack community for the last couple of years, and really like to see the energy and the passion that's going on there. So yeah, I am a technology evangelist at ActiveState. A little bit about my background. My whole career I've been a developer at a variety of companies, doing a whole bunch of different things at Next and Sun and a bunch of smaller outfits, including startups in the smart grid space and utility industry space. And over these years, I've been constantly battling the same battles, which is getting mired in the weeds of software development. So I want to build cool software. I want to build cool applications. Excuse me. And I'm able to do that, but there's a great cost, which is fiddling down in the inner world of trying to get all the the infrastructure working and all the plumbing in the weeds together. And I find that depending on the organization of the team and the size of the team, I was spending most of my time, or a big chunk of my time, dealing with all the operations side, when really I want to build software and get that out the door. Basically, the idea is to successfully deliver software. So I'm saying this just to give a little bit of a idea of where I'm coming from here. I tend to look at things from a developer point of view, with the end goal of getting software out the door, and that's generally how I'll be approaching this presentation today. And with that, I'd also like to say that 2 years ago, I was poking around on the web and I discovered for the first time, I guess it was 2.5 years ago, I discovered Platform as a Service. I saw Staccato mentioned somewhere. I read a bunch of white papers and web pages about it. I didn't understand the whole purpose of it. I didn't get it. Even after reading all this information, I guess I was just a little slow absorbing it. And but what I did was I downloaded the Staccato PaaS onto my laptop, my Mac at the time, and booted it up and tried deploying an application to it. And that moment was one of the more significant moments in my career. The moment I was able to do that, I was almost shocked at how simple it was. And I was seeing years of, the last decades of my development career, all these months I could have saved over that time if I had had access to a tool such as this. So I called up ActiveState and I said, do you have a software developer job open at the moment, a Java developer? And they said, well, we don't have development position open at the moment, but we do have an evangelist role. And so I said, okay, I'll take it. And so I did. And what I'd like to do just to get started with this presentation is show you the experience I had back then. And it'll just take me a couple of minutes or even less to do so. So Raphael, feel free to interrupt if you have any comments as I'm going through this.
Sure.
And so all I did was I went to the ActiveState site. So now I'm showing my browser here. And let me know if you can't see this, Raphael. Go to ActiveState.com. All I did was, after reading the white papers, etc., about their PaaS, I just clicked the download link, and click this thing that says download a free microcloud. And then it gives me a bunch of different formats I can download it in. There's VMware, vSphere, etc. VirtualBox should be here. And I just click, let's say, the VMware Fusion download link. I click that, download it, boot it up in VMware. So that took me, most of the time that took was downloading the bits, which is about 1.2 gigs or something. So it took a couple of minutes for that. Then I booted it up, took another minute or so. And then I had a VM booted in VMware, so something we have all done. And I just did that earlier this morning. Once it's booted, here's what I was looking at is this VMware TTY console showing me that my VM is up and running. And it has some information here. I can log into this using the TTY and just issue commands or whatever, but I didn't know what commands to issue, but I see it conveniently points me to a URL. It says, the Staccato Management Console is at https://staccato-gy2z.local. So I thought, oh, cool, so I'll just enter that. So I went ahead and typed that URL into my browser, and I've done that earlier this morning. So I typed that in. So this morning I just created my credentials just to make this a little faster. It took me all of one screen. And now I'll log into this system. This is what I was seeing 2.5 years ago. And what I did, and I'll get into this in more detail later, is I clicked the deploy an app from the App Store link. And again, later on we'll get into all the details of that. And this is the app I chose. Here there's a bunch of apps listed in different languages like Java and Perl and Ruby, etc. Clojure. I found this Python app called the Bottle Currency Converter. And I clicked deploy app to this thing, and it asked me a couple of things which I didn't understand, and I clicked enter, and I saw this log stream show up, which was showing me the status of this application being deployed. And basically, all the steps involved here, I'll let you go down for a minute. The steps involved here were download a VM, boot it up in VMware, hit a URL, create a username, log into the username, and then deploy an application. And it took me maybe all of 7 minutes or something in total, maybe 10 minutes to get this. And while that's running, I'm going to get back to my slideshow here. And as I said, having seen those steps in action, I realized how much time and effort would have been saved over my career of doing things that you'll see over this presentation, things like setting up logging servers and monitoring and deploying software packages like Ruby or Java and various frameworks like Spring associated with that. So a lot of time that I had spent over and over doing this, including things like continuous integration and delivery systems as well, deployment systems, automation, all kind of went away, and it just boggled my mind. So that's how I got here. That's how I got to this place. And let's just see here. Wait for this to load. I did this earlier this morning, and it was rather rapid. I'm not sure if my network is being compromised. I can slow it down a little bit. This webinar shouldn't be. Well, I'll tell you what. What I'm going to do is I'm going to move on to the presentation and then show you this running in a second. Because for some reason it hasn't deployed. It should have deployed about a minute ago. So it's always the demo guides getting in the way. So what I'm going to do now is I'm going to go into a little bit of a discussion about PaaS. And again, Raphael, feel free to stop me at any time if you have any comments or questions. And I'm going to start kind of at square one. Most of you probably are familiar with this, but I go to a lot of conferences and I have tons of discussions with people. And one of the things I always ask almost at the beginning of the conversation is just how much familiarity do you have with platform as a service? And so I always, when I start a presentation, I like to frame it this way. And so obviously everybody on this call is familiar probably with all of these concepts, but I just want to make sure it's very clear that infrastructure is what provides the resources, the hardware and the network and everything. And what we're trying to produce here, the whole goal here is to provide software as a service. And there's tons of these software as a service things out of here, backup as a service, and I don't know, compliance as a service, desktop as a service, email as a service, and HR as a service. There's tons of these things. Which reminds me, what's the funniest AAS service name out there? I think it's HR as a service, because if you pronounce it out, maybe I'll let you pronounce it out. What I get is harass, which is kind of the opposite of what HR is supposed to do. Anyway.
Exactly.
Okay, having said that, so the whole goal here is to produce software as a service, and it could be done directly on the infrastructure. But what the PaaS does is it provides a platform for developers to build these SaaS applications. And what I mean by that is it provides most things that typical enterprise applications need without having to configure and install and download and even understand all the underlying process and tools and everything that's underneath this. Back in the old days, I was spending ages. Let's say we decided to go with MongoDB at one point, and it took ages, not ages, but it took long enough to get everything in place to actually get to the point where we could deploy an app to a MongoDB database, configuring servers and figuring out, everything we had to do. With the PaaS, it's all just there. It's all ready to go. And as you'll see over the next few minutes, you'll see how simple it is to deploy arbitrary apps to the PaaS. So that's what I'll be looking at here. I'm just going to go back to my. So for some reason, I think it's to do with my network. This thing hasn't deployed, which is frustrating because I really want to show how this is working. And so in that case, what I'm going to do is deploy the same thing to another PaaS instance. You won't see anything different here. I'll just click Deploy an App from the App Store. I'm going to click Deploy App, Bottle Currency, and choose a space and click Deploy. So it's the same steps you saw earlier. And I'm just going to kick this off again, and hopefully it'll run on this instance. Almost certainly will. I'm not sure what's going on with my network here. So I'll let that run in the background for a sec. And so we made the distinction between infrastructure, platform, and software. Again, platform is for developers to produce SaaS applications running in the cloud, running on the enterprise, wherever it happens to be. So how's that sound so far, Rafael?
Yeah, sounds good. Sounds good. So just a reminder to all the participants that are with us, feel free to ask questions along the way as John is presenting and demoing. Great.
So I do want to make a very important distinction here. This is something, as I said, I go to a lot of conferences, talk to tons of people in the industry about platform as a service. And because of the way this thing has evolved, there's always confusion about this. And the confusion is the distinction between public and private PaaS. And the reason for this is PaaS originally got started in the old days with Heroku. Back to presentation mode. Back with Heroku, which was more recently acquired by Salesforce. Heroku was kind of the first famous public PaaS out there, and it was Ruby oriented, and it allowed Ruby developers, Ruby on Rails especially developers, to they've got all their Rails apps developed and ready to go, and allowed them to, with a single command or two, deploy their Ruby app to a full stack cloud instance out there somewhere in the Heroku servers out there. And it saves the developer from having to configure all the things that they normally would have to configure, like load balancers and everything else they needed to do. So it was kind of a revolutionary concept, saving developers tons of time. And Heroku took care of all of the underlying plumbing, so to speak, allowing the developers to just focus on developing software and delivering it out there to the cloud. So, so that was kind of the first kind of mainstream PaaS out there. And since then, there's quite a few following in their footsteps. And many of for years, PaaS was mostly publicly hosted. There was CloudBees, Google App Engine, and Elastic Beanstalk on AWS, and .cloud, who were the originators of Docker, created a public PaaS, IBM Bluemix. There's a whole bunch of these things. These are public PaaS, and what is meant by a public PaaS is that it is in the public cloud, or it's in the cloud out there. The PaaS itself is hosted on somebody's server somewhere, and they can be accessed from around the world. And it's a powerful concept. Me as a software developer or my company doesn't have to worry about building up racks of servers and dealing with things like backups and all the other things that I would normally have to deal with. I just push my apps to the cloud and I'm done. Powerful concept, but there's been a big limitation there in that a lot of enterprises and organizations are unwilling or unable, due to regulations, etc., to deploy their data to the public cloud. And you could look at that in one way as like, how many banks today run on AWS? Probably none, I don't think. And the reason for that is the banks are maybe a little uncomfortable about having all their customers' data out in a data center that's shared by all of their competitors and all sorts of who knows else what other entities. And also many or most organizations, many organizations have their own data centers on site anyway. So this is all naturally fitting in with the whole OpenStack story. And it also naturally evolved into private PaaS. So what a private PaaS is simply a PaaS that can run anywhere, really. It can run in the private cloud. It can run in your data center on your own racks, or it can run out on AWS or run out anywhere, run on OpenStack, wherever that happens to be running. That's the whole point. But it's a very important distinction to keep in mind, the difference between a private PaaS and a public PaaS. So in the case of Staccato, which is a Cloud Foundry-based PaaS, it is basically something, it's a software application or software product you can install on your laptop, or you can install it on your OpenStack instances in your data center, or you can install it out on AWS or on CloudStack or Cloud, or any of VMware, any of the VMware cloud infrastructures. You can just install them anywhere out there. So very important distinction to make. And what I'm going to be talking about today is private PaaS. But again, private PaaS can run in the public cloud. So, okay, back to this again. So I've deployed this application. All I did was click the deploy button. Now I click the start button, and this will have the effect of starting the application. So I'm going to let that start for a second. It shouldn't take too long. And let's go back here. Yeah, for some reason this has not happened recently. This application I deployed earlier just doesn't want to deploy. I'll blame my network. And continue on with my discussion here. So distinguishing between private and public. Now I'd like to dive into it a little bit and look at what actually a PaaS contains. What's in the box, so to speak. And there's a lot of things that are included with the PaaS, naturally, because they're designed for common enterprise developers to be able to deploy. Most enterprise apps should be able to be deployed to a PaaS. So looking at this this diagram here, it just shows some of the things that you'll get with the PaaS. And I'm going to start with the second larger box, the middle larger box there, which talks about languages and frameworks. So most PaaSes will include most enterprise languages today, like Java and Ruby and Python and Perl and JavaScript, Node.js, etc. And any of the JVM-based languages like Clojure and Scala. So if you have an application that's being deployed in any of these languages, you can simply push it to the PaaS. You don't have to worry about downloading the packages for your OS for, let's say, Java and Spring, Maven, whatever else you need. It's all just contained, or it's easily made available inside the PaaS with no work at all from the developer. And the same goes for containers or servers like Nginx or Tomcat, Apache Web Server. These are all easily available within the PaaS. Either they're bundled with the PaaS itself, or there are procedures in place to instantly install these and provision them completely out of view of the developer, the team deploying this thing. So that covers the languages and frameworks and servers or containers. In addition, there are a host of other features that the PaaS provides that are common for enterprise applications. I'll start off with logging. I've dealt with logging a ton in the past, and logging has always been a pain in the butt. The reason is because if you've got a distributed application, you have to worry about agents running on every server to make sure it captures the logs. You have to make sure that the logs get aggregated somewhere. You have to concern yourself that disks don't get too full or agents don't stop arbitrarily. It's a big task in itself just to deal with logging, just getting the logs captured. And the PaaS takes that completely away. Logging it just happens automatically. You deploy an application to the PaaS, and the PaaS takes care of capturing the logs and then distributing or directing those to a centralized log aggregation service like Loggly or Splunk or Graylog2 or a host of other ones. So logging just happens out of the box. In addition, related to that is the PaaS will provide some monitoring features, the ability to monitor the state of your application, how many resources are being consumed. We'll look at that later on through the demo. In addition, it should be trivial to wire up your application to an external monitoring service like Nagios or New Relic and a few other ones. So you might have some very customized monitoring requirements. And so it wouldn't make sense to roll all those into the PaaS itself, but New Relic does a fine job collecting and reporting onto a variety of monitoring measurements. And so you should be able to easily, and you can, wire your application up to an external monitoring tool with very little extra work. So that takes care of the monitoring and logging, just a brief discussion. I want to mention data services. So things like databases and messaging services and caching services should all be easily provisioned within the PaaS. Again, without extra work or a lot of downloading or configuring required by the user. MySQL, MongoDB, Postgres, Redis, things like that should be easily available to the developer, and they indeed are. Other services too can be configured using what we call build packs, but there should be a process or an automated way to provision other services as well. Also, there are means to wire up external data services. So obviously, it's impossible or completely out of the question to bundle Oracle with a PaaS. Larry might have something to say about that. So instead, there's ways to wire up your applications to external data services easily, and also for the PaaS to manage, let's say, the Oracle schema from within the PaaS. So it doesn't require a DBA, a database administrator in the middle to deal with all that stuff. Let's see, what else should we say about this? The thing I should mention is, so you'll see at the bottom of this diagram is the infrastructure layer. And the PaaS ideally should be agnostic to the infrastructure. And you see here that Staccato will run on a variety of infrastructure layers, VMware and AWS, KVM, CloudStack, etc. And of course, OpenStack is well represented there. PaaS runs really nicely on OpenStack, or Staccato does, I should say. So we'll look at that in more detail shortly. So what I've done is I've deployed this application. I'm going to now, if you look through this thing, it'll show a URL for it, but I'll just click this View Application button. And it shows me a URL in the browser, bottle-currency-0vnrb, and then an IP address .xip.io. Actually, if you were to try this at home, you could hit this same bottle currency converter that I just deployed to the PaaS, because this is in the public cloud. It's running on OpenStack, actually. So I was, for some reason, I wasn't able to get it working on my home laptop, and I'll look at that later. But this is the exact same experience, and it actually illustrates a really good point, which I'll get to shortly. First, let's look at the app. Trivial application. It shows currency conversion between various country currencies. It's a trivial app, but it does illustrate the point. It actually is a full stack application. There's a Redis data service sitting underneath this thing, presumably to store the countries and the currencies. It's also calling out a web service at some banker somewhere that's determining the currency as of this minute. So I can see the actual currency conversions. And then there is a user interface layer that's running in a browser. This is a Python app based on a Python bottle framework. Trivial application, but it's a full stack application, 3-tier application that was deployed effectively with a single button click. And this is the thing that I saw that just made me, I had to stand up from my chair and pace around the room for about 20 minutes just to let the impact of this absorb. It really was significant for me. And my role as evangelist here, my biggest challenge is try to convey this significance to the rest of the world. So that's what I'm trying to do today. So moving on. Oh yeah, and I did want to illustrate the point. So earlier I had unsuccessfully deployed this thing to my laptop version. It could be I'm out of memory or something out of disk space on this thing. But what I did then was just in a couple of seconds, I navigated over to an OpenStack hosted version of my PaaS and was able to deploy the app with the same exact sequence of operations. I just went to the same click deploy an app from the App Store, and I found my currency converter and click deploy. So this illustrates a very key point that I'd like to convey today, is that the PaaS is identical. The viewpoint of the PaaS is absolutely identical, whether you're running it on your laptop or running on OpenStack or on vSphere or on CloudStack or any of the various infrastructures. It also means that if you have an application running today on AWS that's running on Staccato or on the PaaS running on AWS, you can migrate it to OpenStack with no work whatsoever, because the PaaS provides an abstraction layer between the infrastructure, go back up here, it's an abstraction layer between the infrastructure layer and the application layer. So migrating applications is trivial. Moving from various clouds is trivial. The learning curve is very, very, very gentle. Moving from, let's say, AWS to OpenStack, there's very little work. So if your team is versed in vSphere or vCenter, for example, and your team wanted to move to OpenStack, if you're using a PaaS, there's actually no impact or visibility to the developer. They just don't care at all. So it's basically it's abstraction layer. It takes the developer away from dealing with the underlying, let's say, the plumbing or the weeds, as I like to say. So okay, back to, let's see, presentation. And then what I'll do is I'll just little bit more discussion on the architecture of this thing so you can see how it works. Staccato is configured as a number of VMs that collaborate as part of a cluster. So a cluster of VMs that all perform the roles of the PaaS. And that is represented in this diagram by the grayed out box. Everything inside that box is the PaaS. That might be a single VM. It might be a rack of servers, each contributing servers for various roles. It might be an entire data center or spanning data centers that is conceptually this PaaS. So whether it's a VM or a data center, it's the same discussion. And inside the gray box or at the edge is the load balancer. So traffic coming in from the outside, from your application users or PaaS users, first goes to the load balancer, which load balances between two routers, or a number of routers we have, one or more routers. And then the router's responsibility is to route the traffic to the application instances themselves. The app instances run on these components called DEAs. It stands for Droplet Execution Agents. You can consider these as virtual machines that are responsible for running your apps. Their DEA is a component running in the PaaS, and it takes care of running the application. It has agents installed there to track the apps, restart it. The PaaS itself can move things around. So the DEAs are responsible for running the applications. You can have any number of those available in the PaaS. Again, those are VMs, or can be considered as VMs. On the right-hand side, we have a number of things we talked about. First of all, I'll mention the Harbor Port Service. This allows the routing of arbitrary traffic, whether it's TCP or UDP, whether it's HTTP or HTTPS or any other protocol, send mail or anything. You know, DNF traffic can go through, it doesn't matter. Harbor will take care of, first of all, if it's not HTTP, I should say, Harbor will take care of routing the traffic through either to the applications or the appropriate services. I slightly misspoke there. The HTTP and HTTPS traffic does go straight to the routers, to the application instances. But the point is, if you have apps listening on non-standard ports, or sorry, not using non-standard protocols, you can use Harbor for that. And then on the right side, we have some of the data services I mentioned, like messaging services, databases. There's a caching service. There's a persistent file system, which can be shared among multiple application instances or across multiple applications. And then kind of the more important component is the cloud controller. It's the orchestrator of this whole thing. It takes care of provisioning applications, monitoring applications, and tracking their status. The cloud controller exposes a REST API, so the PaaS is controlled by you can control it by a REST. Any HTTP client can talk to the PaaS and query it or manage it or control it. And there's health monitoring going on in here. So that's kind of a high-level view, excuse me, of what the PaaS looks like itself. Again, this can be a single VM, or it can be any number of VMs, hundreds or thousands really, that make up this PaaS. So I'll pause there, Raphael, and I'll let you interject anything if you have a need, or I can just keep on going.
I think you should keep going, and if you want to dive into the demo, feel free to do that right now.
Great. Okay. I shall do that. Let me get that right now. So what I'm going to do now is you've seen the PaaS in operation, just a very kind of high-level viewpoint of it. What I did was I booted it up, and with the web browser I was able to log into it and then deploy an application to the App Store. I'm going to just highlight a few of the features of this thing that I find pretty valuable, and that save a lot of time when you're deploying applications to the cloud, or enterprise apps either to the cloud or to your own data center. First thing I'm going to do is I'll go back to that application I deployed earlier, and I'd like to look at some of the things I can do with this application. So this is the bottle currency app I created a few minutes ago. There's a summary that shows the status of this app, how much memory is used, things like that. But you can see it's a Python application, when it was created, and other things. We also provide a timeline here. The timeline is used to basically collaborate with other developers, start discussions. You can see things like when, if a developer starts to talk, they wants to discuss a bug or any other related thing with this application, they can just say, bug 12, fix this, or something like this. Oops. So starting a discussion, allowing the developers to collaborate. So any other developer that's working on this application can see this. It's basically just an internal forum, kind of useful. Another thing I'd like to point out is this application versioning capability. Actually, I'll show that later when I've got another application to deploy, because that's quite powerful. It allows me to deploy multiple versions of an app and then roll back to them instantly. I can also view and inspect environment variables or or actually set or inject new environment variables into the application. There aren't any set for this particular application. The app will need to be restarted for those to take effect. I can see the files that make up this application. So this is a Python application, and I can see if I want to navigate through here, I can look through the source code for this, and here's the whizg.py file that shows the source for this application, or some of the source. I'll go up across multiple files. The next thing I can look at is the instances of this application. I'm going to try to do this on the fly. Hopefully it will work. So the currency converter application that we saw earlier, it's running outside in the cloud. Right now it's probably getting very little traffic unless everybody that's on this webinar is hitting it like crazy, which I kind of doubt. So although feel free to do so. But let's say that this application was about to get a ton of traffic for whatever reason. What I can do in the PaaS is turn on auto scaling. What this sets up is that for the PaaS to detect when the application gets too loaded based on the CPU use, and then it'll spin up new instances of the application itself. So right now there's a single instance of this app running. It's you can see it down here, instance 0, and it says when it was running before. It shows also the IP address of the DEA that it's running on, the Droplet Execution Agent virtual machine that it's running on. It's 10.0.0.70. So what I can do with these sliders is I'll slide this up a bit, and I'll say instead of just 1 to 3 instances, I'll have, let's say, 3 to 7 instances of this application running. So I'm doing this manually, and having done that, now the PaaS has fired up 2 additional instances of the application, and now they're running automatically. I didn't have to do anything to make this happen, as far as dealing with whatever is underneath the covers here, load balancing between these apps and setting up all the logging agents and all the other details I would have to worry about. Again, as a developer, all I did was deploy it, and now I have multiple instances running. And then what I could do, I'm going to bring up the shell here. Do I have? Yes, I do.
While you're demoing, John, there's one question that just came in. Can we roll back an application to any arbitrary version?
Yes, so the question was, yeah, rolling back to an app to an arbitrary version, yes. I'll hopefully get to that shortly. Oh, we got it right here. So when you deploy different versions of applications in any way, and this is an important concept. If you look at the 12-factor app philosophy, a configuration change is a different version. So this is kind of cool. Staccato says that changing the number of instances of an app is a configuration change, and that's how it should be if you follow the 12-factor philosophy. Any source code change or configuration change is considered a version. If I want to roll back to the previous version, I just click this button here, and it will instantly roll back to the version. Probably more relevantly is if you were to make a source code change and re-push the application with the new change, you could roll back to the previous version, and it's an instantaneous process. So yes, short answer to your question is yes. So I don't know if this is actually going to work. Feel free to, if you happen to have Apache Bench running at home, you can feel free to hit the same thing yourself. I'm hitting the app hard with Apache Bench, I think, and ideally, if it's going to load it down, the number of instances will increase. It doesn't really matter if they do or not, because I think the point is illustrated here. When the CPU threshold gets too low, that is too high. If it exceeds that value, if CPU usage exceeds that threshold, then the number of instances will be increased. We do that, by the way, by our applications are running in Docker containers. So under the covers with Staccato, it's very easy to spawn up new instances. It happens very quickly. The next thing we can look at is the log stream. So I said it earlier, logging is all taken care of by Staccato. All application instances running in the cloud will send their logs to to basically, they'll all be collected by Staccato, and then they can be redirected to the centralized log aggregator like Splunk or whatever. And you can see them in the console here, which is handy to see. I don't typically use the web browser-based console to look at logs because it's a little bit cumbersome. But there's certainly nothing preventing you from doing that. But you can also send these off to anywhere you want, including you can capture them in a file and use Unix utilities to capture or analyze your logs. Another thing you can do is routes are just basically the URI to access your application. You can create as many of these routes as you'd like. I can call this thing, I'll call this JDW10. To a new route here for this application. And so now, if this works, I should be able to get this. And it looks like well, I must have copied and pasted it wrong. Okay. Yeah, just copy paste that. See if that works. Yeah. So as you see, I created a new URI for this application. As long as it's as long as the domain name is being mapped properly in the DNS, this will work just fine. Okay. So I better watch out for time. I see that things we're already 40 minutes into the hour. So I'm going to fly through some of this rather quickly. The next thing I want to mention is clustering. I mentioned earlier when we looked at the architecture diagram that this Staccato instance is consisting of one or more VMs participating or collaborating to build a cluster. So looking back at the web console here, I can look at the nodes that make up this cluster, and I can see the roles they have been assigned. So here we have 6 nodes that are making up this cluster. These are all VMs basically running an OpenStack. You can see their internal IP address. And you can also see the roles they have been assigned. So every node needs this base role, basically just the foundation of Staccato. And then it shows the other roles that are assigned to it. So for example, this .72 node here has, in addition to the base node, it's being tagged as the primary node, kind of the first one here, the controller of this whole thing. It has the cloud controller running. That's the one that exposes the REST API and deals with the orchestration. And it also has a router running on it. Then we'll look down at .73 here. And it is a data services node. So it contains a number of data services, Postgres, MySQL, MongoDB, etc. So that particular node is taking care of all of those. .70, .71, and .51 are DEAs, so they're responsible for running applications. And this is kind of a typical setup that you would see. Data services running on a node, any number of DEAs depending on your application load. And then one node responsible for routing. However, you can add as many nodes as you like, and these can easily be configured. So if you'd like to change this, you can do so by clicking the gear on the right and then just adding a service or anything else that you need to this node. I won't change this one here, but just to give you an idea. So you might want to split up those data services amongst multiple VMs, or you might want to disable some of them if you're not using, let's say, Postgres. You can just disable it altogether. So that shows you some of clustering. There's a number of other features I could dive into here, but I'm sensitive of time, and there is something I really do want to show. But I'll dive into the dashboards quickly. With the dashboards here on the console, you can view basically what's going on with your PaaS, the memory and the resources being used, how many apps are running, see the physical memory, the reported, etc. See how many requests are coming in, the total number of requests that have hit this thing, and other things, how much memory, CPU, etc. So I'm rapidly running through these things. I just wanted to show you that they're available. Again, I mentioned earlier that the PaaS takes care of some monitoring, and we're looking at this here. We're able to monitor the state of the PaaS. But in addition, you can tie all this to an external monitoring service like New Relic. So what I'd like to show you quickly, since this is actually an OpenStack meetup, I'd like to, or whatever this is, webinar, I'd like to show you something that I did a few months ago. And because it would have been much too cumbersome to do this live, and it would have taken longer than we have taken, 10 minutes. I'm going to run through this really quickly. What I did was on OpenStack, I created, I just uploaded a template, a VM template of Staccato, and my requirement was to create a large cluster of this in a very short period of time. And it was very trivial to do so. I took a Staccato VM image, I modified user data, I added a single directive in there to point the Staccato PaaS to the kind of the primary node, which I had previously booted. So the steps were boot up a primary node, and then modify the template, add user data to point to that thing, and then boot up the template. And what I did was I actually booted up multiple versions, multiple instances. And that's what I'm looking at here. So here, what I had just seen was, well, let me go back. Sorry about that. Switched too fast. What we have here is it's showing the Staccato setup like I showed you earlier, the cluster admin. We've only got 2 nodes set up here. And then what I did was I logged it. This was Cloud Scaling back when Cloud Scaling was its own company. They provided me all these instances, and I was running Horizon here. So what I did was then I basically asked it to spin up a new instance, and I found the image that I'd set up. I'm just going to let this run. I guess it's caching. All right, I'm going to describe it first because it's. I wonder what's going on. I wonder if it's when I up a network bandwidth. All right, you know what? I'm probably just going to have to talk through this, but it's well worth talking about. I've told you earlier what I just did was set up a template which pointed to the core node. And then what I did was I asked Horizon to boot up 100 instances of Staccato. And it took about 7 minutes to boot this thing up. And after the 7 minutes, Staccato was completely running. The 100 node cluster was completely running. I really want to show this. So this should. So, and my Kathy, when she sees the old marketing here, but so what I did was I logged into Cloud Scaling, and I asked it to create a new instance. And so you just say, new instance. And I said the instance name, Staccato DEA. Again, this is a droplet execution agent. It's a M1.medium or whatever that was. I set up the networking. Now it boots up these 100 instances of Staccato. And you've all noticed if you use OpenStack, it's just booting up VMs. It's as trivial as that. It took me about 7 minutes, if I remember. Yeah, 7 minutes to get through this whole thing. And once that was done, I reloaded the cluster admin page. And now, as you can see, there are 100 nodes. They're all DEA nodes, but there's 100 nodes participating in this Staccato cluster. So I wanted to show you that. The whole point is there's very little work or effort involved in getting a large production-ready cluster of Staccato instances running in the cloud. Hardly any work at all. So it's now, we've got about 10 minutes left. I do want to bring attention to this quote that my CTO sent out a month ago or so. This is from NewStack. And it's kind of the trend with development these days, with enterprise software development, or at least where it's going. I believe this deeply after my experiences in the field and talking to tons of developers and enterprise, IT folks. The whole trend is to give power to developers to write modern data center scale applications against an aggregation of all the resources in the data center. That part of the quote really jumped out at me. And what this means is the developer writes against this aggregation of resources, but they don't have to worry about the underlying plumbing. They can get out of the weeds and just build the applications and deploy them. So, another thing, this is from Bernard Golden, one of my colleagues. He says the battle of the infrastructure is over, and OpenStack is clearly in the lead there. But the battle of the applications is about to begin, and platform as a service is what's, in my view, an essential component of that. So there's tons more I could show you with Staccato, logging and monitoring and various things, rolling back versions. But I think now would be a good time to pause, and I'll let anybody, Raphael, or anybody out in the audience, if you have any questions you'd like to discuss, be open to them.
Sure. Thank you very much for both the demo and the presentation, John. A brief note on the side to our audience, since Active State is sponsoring the Cloud Online Meetup, we're going to have several more sessions, and I guess that this will be a great opportunity to dive deeper into the integration points between Staccato and OpenStack.
Yeah, great.
I see that someone raised his hand, so I am assuming that the question will pop in just a minute or two. But in the meantime, maybe can we talk a little bit about the world of microservices? How does that look from the PaaS perspective?
Great, yeah. Microservices is one of my biggest passions these days. It's gaining huge momentum. Netflix, Adrian Cockcroft and Netflix did major pioneering work behind it, so it's really, as you might be aware, it's really making a lot of traction. PaaS is almost an essential piece of microservice development. There's a lot of things with microservices that it would be almost impossible to do without tooling in place. And by tooling, I mean most of the things that the PaaS provides. So I don't probably have time to dive into too much about microservices. That could be an hour right in itself. But with microservices, you have a lot of small, very small, contained, isolated components that are very specialized services, basically, and they communicate over a REST API or over a message bus or some other internal protocol. And they have a single task they need to get done, and then all of these services collaborate together. This is in contrast to the old style of big monolithic three-tier applications where you have these massive WAR files, megabytes of WAR files that contain your application, maybe gigabytes, where it's very difficult to redeploy the application. It takes weeks to get everything redeployed. This way, you could just, if there's a microservice that needs to be redeployed, you can do so instantly. And the PaaS is an ideal platform for that. By definition, microservices, you can have hundreds of them, each of them are divided up in different languages, let's say Perl and Python and Java. And they're all collaborating. So the PaaS enables you to deploy those things. But more importantly, it provides the ability to automatically monitor and log these things and take care of restarting them if they need to be restarted, routing to them, all the underlying headaches that you shouldn't have to deal with, rolling back versions. I wouldn't even consider building or architecting a microservices application without using a PaaS of some sort. And the modern PaaSes that are out there today, like Staccato and Cloud Foundry, et cetera, are ideal for a microservices deployment. So definitely, if you're considering a move to microservices, look hard at the tooling available and follow where the other pioneers of microservices have gone. And whether it's Netflix or others, whether they roll their own or they use an off-the-shelf PaaS product, they are definitely using a PaaS to provision microservices.
John, another question that just came in from the audience. How big and what would be the role of the admin in the production environment?
The admin, okay, the role of the admin. So I'll talk about Staccato here. And I actually brought up this slide. This is a convenient way to bring this up. But the admin would be responsible for making sure the PaaS is provisioned. They'd also be responsible for dealing with all the underlying things you would expect, dealing with the resources. So make sure if you're in the data center, making sure the servers are operational and the network and everything. So from the audience in this webinar, everybody's familiar with OpenStack. The OpenStack side, the infrastructure side, still is the requirement of the admin person. But as far as getting the PaaS operational on it, there's very little work. As you saw earlier, it's basically booting a few VMs and some very minimal configuration changes. And then after that, there's maybe another role, but it would be administering the PaaS itself. And that involves creating users and organizations of users and managing the users in those organizations. And assigning quotas to those organizations and things like that, basically PaaS operational tasks that are involved there. It's very straightforward to administer the PaaS, as we looked at before. It can all be accomplished via the web console, and there's this admin menu where you can see let's say the organizations that have been created and the users. So this is a fully multi-tenant PaaS here, as you might expect. Yeah, so the actual roles, there's basically the resources, the underlying infrastructure roles, and then managing the PaaS itself. The PaaS is fairly straightforward to administer. And I'm kind of glad you mentioned that, because I did want to mention this one point, which is that everything you've seen as far as managing and accessing and using the PaaS can be accomplished by this web console we've been looking at here. It can also be managed by a command line, or by plugins from an IDE if you're a developer, or via a continuous integration tool like Jenkins, for example, or Bamboo. And the reason this can all happen so easily is because everything is exposed through REST. So you can automate the PaaS operation externally by anything that can talk HTTP. Very simple to automate with any HTTP client. So perhaps a deployment team would be using this to integrate it in with Jenkins. Very straightforward to do. I hope I kind of answered your question. I think I went around the map there a bit, but I hope I covered what you asked.
Thank you, John. There's one more question for the audience, and I guess this will be the last one for today, which is how large are Stackato deployments that are currently in production?
That's a good question, and I don't know the answer to that, although I should. I will admit that I'm kind of caught in the weeds myself. And what I mean is I really focus on the technology, and I've got my blinders on a bit with the external world. But so as you saw earlier, I was easily able to create a 100-node Stackato cluster. That was trivial to do, consisting of terabytes of memory in total. I'm hesitant to guess, but I'm pretty sure that our customers are using multiple hundred node clusters out there.
Since we are planned to have at least 3 to 4 further sessions over the next 3 to 4 months, maybe we can get to back to that question. What do you think about that? Probably we're going to be able to answer all the questions today, but
yeah, I will make sure that right after this call, I will research that and get a good answer, because I really should know that.
Yeah, thanks. Well, there's another one. Let's take this one. Can Stackato run on bare metal?
So it can technically. We don't support it officially. In other words, it's just a VM, so you can boot it, but we don't support it officially ourselves. But if you have interest in running it on bare metal, certainly contact us, and we can make it happen very likely. But it's just a VM you boot, so you can boot it on VMware Fusion, or you can just boot it on a bare server.
All right. We are pretty much done. It's 10 a.m. Pacific, or depending on the time zone you're in, it might be a little bit later or earlier. John, thank you very much both for the presentation and for the demo. As I mentioned, we're going to have a few more sessions, so we are certainly going to dive specifically into how Stackato wires with OpenStack. That's one of the topics that we're certainly going to cover in upcoming sessions. We have 1 minute left. Where's the Q&A and dev operations?
I'm sorry, I missed the question.
Where are your Q&A and dev development operations?
Oh, you're talking about ActiveState? Yeah, we are based in Vancouver, Canada. So most of the company is up in Vancouver, and then other employees are distributed elsewhere. But what you asked, dev and QA is up in Vancouver, Canada. I happen to be exactly 1,000 miles south of that in Santa Cruz, California myself. That's where I'm at right now.
Okay. John, thank you very much.
Okay, Raphael, my
much.
pleasure. Yeah, it's been my pleasure, big time. Thanks for asking me.
Thank you guys. Thank you guys for joining us.